Hello and welcome to this video on how bleach is an antimicrobial and what it is doing for you. And now to be clear before we get into the details, bleach as an antimicrobial is simply because that is the broadest application it has. Some of the features it has specific to microbes, and particularly in terms of bacteria, may not necessarily translate to, say, viruses, fungi, or anything else. On the other hand, most of what it does with bacteria in particular, at least some of it, will apply. So you'll find that its broadest application is an antimicrobial, and that is everything microscopic. But in terms of what it actually does functionally, the most accurate use is an antibacterial agent, but it will cover other things as well. Now, if you want to sterilize and sanitize your brewing equipment with the smallest possible budget, then bleach is going to be your friend. It's good for more than just cleaning up crime scenes. This also means it can prove to be a cheap, effective and reliable option that costs very little by comparison to specialized commercial products. That does not mean bleach is without any downsides, but by comparison is the best option for those who want to stretch their dollar as far as they can go, which is an entirely understandable position in the current economic environment. Bleach in this context is the common name for a chemical used both commercially and domestically, made primarily with sodium hypochlorite. This is distinct from bleach in the chemical sense, which is a process shared with the common chemical name bleach, but can also be achieved by other methods such as light. The most commonly used chlorine-releasing agent is going to be called sodium hypochlorite. This is universally just called bleach, which is much easier to remember. It is characterized by its very good antimicrobial abilities. It's very low in toxicity to humans, it's very low in cost, but it is something of an irritant and somewhat corrosive, which is one of its major downsides. But that also brings us to the active ingredient of interest, sodium hypochlorite. Sodium hypochlorite is a chemical that is seemingly very simple. It's simply a sodium attached to an oxygen, which in turn is attached to a chlorine molecule. These elements do break down into an anion of hypochlorite, or oxygen and chlorine, and a cation of sodium. Once sodium hypochlorite dissolves in water, you'll get two compounds. That is what effectively causes all of its disinfection functionality. Now, some of this is done via oxidation, and that's primarily through the hypochlorite, which is a weak base, or as the corresponding weak acid, which is hypochlorous acid. The percentage of this will be somewhat determined, let's say, by the water's pH, as the free hydrogen ions will effectively decide on its activity, to an extent anyway. In this case, we have both a positive charge to the sodium and a negative charge to the hypochlorite, and this is an important thing to be aware of. Both the anion and cation are effectively a major reason that bleach works as an antimicrobial, and more broadly as a sterilising agent. Bleach, and to a certain extent high temperatures, actually have much of the same effect on proteins, and this is one of the reasons why it works so well. Rather than having to autoclave all your equipment, which is high pressure and high heat, you can just use sodium hypochlorite or bleach, as it will cause proteins to lose their structure and they end up forming large aggregates. Basically, they clump together unexpectedly, sort of like cat fur, which makes fur balls. Further, many of the proteins that are affected like this tend to be pretty damn essential for bacterial growth. So once you start inactivating these and causing them to play up, you end up killing the bacteria. One, for lack of a better way of putting it, expression for this is you cannot unboil an egg, and cells cannot deal well with aggregates in the same way. They simply can't take care of what's happened. Now, we've mentioned how pH value is kind of important, and this is not something that can be underestimated. It won't be the be-all and end-all, but it is a significant factor. And not only is it going to affect its activity levels, but it's also going to change its shelf life. At slightly above room temperature, that's about 25 degrees Celsius, up to as high as 35 degrees Celsius. At a pH of 7, so neutral, your sodium chloride solution will actually expire in a few hours, and that's because it will vaporize off and effectively deactivate. If it's a higher pH, it'll actually last longer at a higher temperature. And at a very high pH, somewhere between 9 and 10, even as high as 11, it'll last for up to a month. But for most applications, we're going to be talking about fairly standard pH levels. That is, once you actually apply it to the surface, whatever you're trying to sanitize. This does bring us to what's happening inside of your bacteria though. And for that matter, as mentioned, it could be anything else, including fungi, viruses, protozoa, or anything else. But particularly targeted, according to at least one major recent study, is something called HSP33. This is a protein, and its job is to chaperone around other proteins, and in short, not only do they maintain their shape, but they go where they're meant to go. When this is in bacteria, it ensures that proteins will refold and reform once a stressful situation has passed, and this allows the bacteria to survive. In terms of bacteria though, and for that matter other microorganisms you're trying to get rid of, there is no respite from bleach in this context. It's kind of like high school. You want it to be over, but it seems to take forever, and in hindsight you regret that desire. And more so when rather than waiting between 3 and 6 years for the end of suffering, you only need to wait 10 to 60 minutes, or at least that's the duration of application, which is actually a fairly short amount of time when you consider that everything else you might apply is a very similar time frame, if not longer. Further, if your bacteria in particular are sensitive, let's say, to cell stress, and particularly that caused by bleach preventing proteins from being able to work properly, they're much less likely to cause problems. And we don't just mean in terms of having to pray to the porcelain throne due to food poisoning. We mean things like infection as well, for instance. That's why, in some ways, chlorine is really good, because the biggest worry you might have is actually going to be something like spores, and chlorine-based compounds are very good at dealing with spore formers, and as a result, you can use it with a reasonable amount of confidence in those terms. So for example, if you're canning. The other benefit to all of this is that not only is it fast acting, but it's an oxidizing agent as well, which is a further way to damage your, let's say, a nemesis in the form of microbes, but it is broad spectrum in its activity, and this means not just in terms of bacteria, but it works against just about everything. Now, we have focused for the most part on bacteria in this video, but bacterial spores are another big one, and as mentioned, particularly with canning. Canning is where spores can be a problem because they can survive for so much longer, and then they come back alive once you open up the can, and then you suddenly have botulism. Viruses are a fairly, a topical one over the last few years. Fungi, similar. But on top of all of this, because it reacts so well with a protein initially, but other things as well, it can lead to cell death very quickly and very easily. And if it doesn't lead to cell death itself, it damages those cells in such a way that they may not be able to survive, or at least that they can't continue to divide. It damages things like lipids, carbohydrates, DNA, and RNA. And this is one reason why you don't use bleach on yourself, unlike some idiots who seem to think that it's some sort of miracle cure. But also, much like with the antimicrobial application in this video, it'll cause just as much damage to your cells, and this will end up killing them. Thankfully, in most brewers' situation, it's going to be the application of inside, say, a fermenting tank, a vessel of some description, your equipment, the things that'll never go inside you, we hope. And as a result, you don't really need to worry about that, as long as you clean up after you're done. And further to that, the chances of you having to worry about this developing resistances down the track, practically no evidence exists that bacteria can develop resistance to bleach under normal usage conditions. So that is, unless you happen to be doing something truly bizarre and weird, you're never going to have to worry about this coming back to bite you in the arse. This is how bleach makes your equipment safe to brew in, use, and ensure your bottle of favourite alcoholic beverage leads to a slight feeling of relaxation and enjoyment, and not diarrhea so bad it will stain the very land on which your toilet is built, with memories of your fiery fluid excrement. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. Please do post any comments, questions, or suggestions you have below.